So we shall continue. Yeah, so I can see. Okay, so we're going to continue. This is the we continue the water cycle, right? It's about the evaporation, condensation, and all that stuff, right? The water cycle. So let's continue here. Right, so we have a diagram shows two similar empty glass dishes. Okay, so this is at 3 degrees Celsius, 0 to 120 degrees Celsius. After 1 hour, both dishes were removed and placed on a table in a room, 30 degrees Celsius. So that's like room temperature, correct? So on which one would water droplets be observed after some time? Is it a cold one or the hot one?
Cold one.
Hot one. Water droplets, Water droplets. Okay, first of all, where would the water droplets be coming from?
Hotter region.
Where is the hotter region?
Surrounding.
Yeah, the surrounding, right? So if the surrounding is hotter than what? Hotter than the dish, right? So the answer is actually dish X. Why? Okay, let me type down the answer first. So first, you will observe water droplets on dish. What just happened? Okay, we will see it on dish X, right? Why is it on dish X?
You touch the cooler surface.
Yeah, because the warm water vapor from the surrounding. This one is a bit too big. Okay, the warm water vapor from the surrounding air would come into contact with the cooler surface of the dish. It loses heat and condense into water droplets. Okay, so it's not going to happen to this one. Why? Because it's 120 degrees Celsius. It's too hot. The water vapor will not condense here. It will condense here, right, on the cold dish. Oops. Okay. Can you see that? Right. So you understand what's going on here, right? Okay, great. So next one. So Sharon was driving. When it started to rain, she noticed a layer of mist forming on the inner surface. So this is the inner surface. So what could Sharon infer about the temperature inside and outside?
Temperature outside is warmer.
Nope. Now the mist is inside, no? Mist is inside. Okay, look. See, I got an example for you.
Colder.
Where's the mist? Inside, no? Why is it inside? Because outside is cooler than the inside, right? So the water vapor touch the surface. This surface is cold. You know what I mean? It's cold. So it condensed and it became water droplets, right? So we would infer that the outside is, so the temperature outside is cooler than inside, right? So you can infer this immediately. Outside is cooler than the inside, right? If not, it's not going to condense this way. Okay? Then, next. Okay, so Sharon decided to increase the fan speed in the car. So based on your answer, how would this help to stop more mist? So just now outside colder than inside. So now she increased the fan speed. Now what's going to happen when she increases the fan speed?
Temperature will be
Yep. So
colder.
Yeah, so temperature inside will be colder. And then what happens? Are you? Yeah?
The thing like cannot fall.
Yeah, so the mist would disappear. How do you spell disappear? As there is no difference in temperature between inside and outside. Okay? Right? So because there's no difference in temperature, you're not going to see a condensation happening. Right? There's no condensation, it isn't going to happen. You get that part? Right? No condensation. Okay. Simple? This is alright? Condensation is fine, right? See? Can you see that the patterns are always the same type of questions? Alright, so let's take a look, right? So, anima. Wrong, it's amina. Right? So here type anima. So it's like So she observed that the temperatures of the hot water in both containers were decreasing as water droplets disappeared from the outer surface of the containers. Explain Amina's observation. Okay, so we gotta look at what's the difference between the two setups. One is material X. The materials are different, right? So how come one of them takes 3 minutes? This one P takes 3 minutes for the water to disappear. This one takes 9 minutes.
Bad conductor.
You can see this one is actually darker. Yeah, let's see. Q bad conductor. Hot water, cooler surface.
I thought it should form inside.
Yeah, wait 80 degrees Celsius. Oh no, this is not condensation, you know. She spray water outside, right? So don't be confused. It's not condensation, right? She sprayed water outside. So apparently the one over here took a long time to evaporate, but the one over here took a short time to evaporate. So
X is a good conductor.
yeah, very good, right? So X, material X is a good conductor of heat. Explain. Okay, so here we gotta explain her observation. So we know that X is a good conductor of heat, and hence what?
It could gain heat.
Yeah, hence the water droplets gain heat faster and evaporated faster. Right? So it gained more heat and evaporated faster. That's the key idea. So based on Amina's result, what could she conclude about the property of X and Y? Oh, okay. So actually this part is about the property. So here the answer should be material X is a better conductor of heat than material Y. Okay, so this is the conclusion. Right? So that's the conclusion. And that's one page. It's 1 page, 2 sentences. Next one. So actually it looks very thick, right? But actually it's not. Right? It feels very thick. But every page you only have like 1 or 2, and we're definitely going to finish it by today. See? Right? Very fast. Next. Okay, so let's take a look at the setup. 2 containers side by side, table, recorded temperature. Results are shown below. Explain why the temperatures of the hot water decreased with time. Okay, So you see, if we look at the first question, they don't care whether is it the big container or the small container. They just ask why is it the temperature decrease with time?
Because the water gains heat from the surrounding.
What? Eh? No. You put hot water inside. Put hot water inside.
Lost heat.
Ah, very good, right? So now this is applicable for both containers. So we say that the hot water lost heat to the surrounding. Hence, its temperatures decrease with time. Right? Lost heat to the surrounding. This part is okay? They're not asking why difference, huh? Not yet. So based on Joshua's results, state how the surface area and the exposure to air affects the rate. So now we got to study. You see container A. Now which one lost heat faster?
A.
Yeah. So why? Huh?
Because it's surface area, like more space so that it can lose heat.
There's one key word that we're looking for. It starts with the letter E.
Evaporate.
Yeah. Just now you said something about surface area, right?
Exposed area.
Ah, correct, right? So this has more exposed surface area than this one, right? So the reason why, how the surface area exposed, you see water exposed, right? So we will say that the bigger the exposed surface area, the faster the rate of cooling of hot water, right? Okay, now why do we answer this way? Because that's what the question is asking about. They're just asking what is the relationship between the rate of cooling and the amount of water exposed. Okay? So far okay? Easy or not? Okay, your prelim question, was it like, something like that?
It was about like when like there's a rock and then it was cracked and then water went inside. Then after a few months it broke.
Okay.
Then I got stuck.
Oh, you got stuck on that one. Never mind lah. Okay, I'll tell you the reason. It's because of, is it in a cold place?
Spring, summer, water, winter.
Yeah, so because the water inside expand and contract. Why does the water expand and contract? Because it became ice and then became liquid, became ice, became liquid. So when it becomes ice, it expands. So can you imagine water inside the rock and then the water expands? What does it do to the rock?
The rock cannot tahan.
Yeah, but you cannot write the word tahan. Then the examiner, what is the meaning of tahan? You go and read the dictionary. No such word. So what do you say? Cannot take or cannot take the stress of the expansion and contraction. Okay? Therefore it broke. Okay, next one. It's a terrarium. Have you seen a terrarium before? Nope. So there's one over here. So based on the setup, which terrarium, but do you know what's a terrarium? Basically they have all the animals, the organisms inside there, and it's supposed to survive by itself without any help from outside. That means you don't need to water it. It gets its own water from within the environment. So the question is, based on the setups above, which terrarium A or B will have a higher amount of carbon dioxide after 5 hours? This is airtight. There's no snail, but the other one has a snail.
What snail?
Huh? Where? Oh yeah, there's snail. Yeah, alright. So good, there's snail. Yeah, there's snail, right? So which one will have more carbon dioxide? In the cupboard, in the cupboard. Both in the cupboard.
B. Wait. B, I think.
Well, no.
Is it?
A. It's A. How come A? Okay, why is it terrarium A?
No new oxygen.
You see, placed in a cupboard, even though there are plants, can it photosynthesize? No. Yeah, so the plants in terrarium A cannot photosynthesize as it is kept in the dark. Hence, increases. But how about for terrarium B? Can it photosynthesize? Also cannot, but there are holes, right? So in terrarium B, there are holes to let the carbon dioxide out. Hence, there are less carbon dioxide. Right? Okay? Less carbon dioxide. Because the carbon dioxide came out. Right? I know it's a bit long, this lengthy, because you have to explain why there's more here than here. Right? Both cannot photosynthesize, but how come the other one has more? Right? Okay, so should we realize that there were water droplets on the inner side of terrarium A? Explain the observation. Okay.
The water just evaporate.
Yeah, and then?
Condense on the thing.
Yeah, it's the same stuff, So water evaporated and condensed on the cooler surface of the okay, is the condensation story. Right, so water evaporated, condensed on the cooler inner surface area of the terrarium to become water droplets. Sorry, so we got to talk about loose heat, right? Where do we put loose heat? Before condensation, right? So water evaporated came into contact with the cooler inner surface. Okay, just put somewhere, loose heat. So we got to talk about the whole package of condensation, which we spent 1.5 hours talking about last week. Condensation, and we're going to spend another half an hour talking about it this week, right? The condensation, such an interesting concept that they love to test it again and again. As we can see over here, do you know why they like to test that? Okay, because
it's 3 marks.
Yeah, I mean, you look at the whole. You look at this. This is the whole water cycle, right? Which one is most difficult to explain? Is it evaporation? Yeah, condensation is the most difficult to explain. Okay, right? So the hardest questions are usually about condensation. Okay, next. So you see, this is how we can answer questions very quickly. Just look at this. Based on the results, which liquid has the greatest rate of evaporation? PQR, boiling point, and at the start. Oh, yeah. Which one? So they all started with 10. All of them start with 10. After that, this one left 279. So which one is the greatest rate of evaporation? Yeah, P. So we have to give a reason.
Most amount of water.
Yep, loss. So P. It has the most amount of water loss, as shown in the data, right? So describe the relationship between the boiling point and its rate of evaporation. So based on data again. Data. You see, boiling point increase, what happens to the rate of evaporation?
Decrease.
Yeah. So as the boiling point increases, the rate of evaporation decreases. How using identical dishes helps to make an experiment a fair test? Why must we use the same size?
To keep the exposed surface area the
Very
same.
good. Right, to keep the right. So identical dishes helps to keep the exposed area the same because it is a factor, right, that affects the rate of evaporation. Next, see again. Familiar or not now? Yeah, should be right. No big deal. Same stuff. Okay, what happened to the amount of water vapor in the air after 10 minutes? Oh, it's a bit tricky. Come, take a look first. Think about it.
Is it inside the box or inside the cup?
Okay.
Is it inside the box or inside the cup?
Yeah, so you gotta figure out, right? Where you see where is the always figure out where is the cold surface. So if the cold surface is here, water vapor, where's the water vapor? Yeah, it's here, right? So hot water vapor, imagine you come, you touch this thing, right? So where will you become water droplet? Inside or outside?
Outside.
Yeah, very good, right? So the answer is outside. But the question is, what happened to the amount of water vapor after 10 minutes? So decrease, right? Okay, so the amount of right, so we just said, oh no, we gotta explain why. Because it comes into all. Okay, you don't have to type out again. Just write condensation package dot, right? But I'll just type it out. It comes into contact with the cooler surface.
What is for condensation?
CONDENSATION. Okay, it comes into contact with the cooler surface of the cup, of the glass, loses heat, and condenses into water droplets. Okay, can you see that in one sentence I have everything? The most important thing. What are the most important things? Come into contact with the cooler surface. Come contact cool surface, lose heat, and the super duper important word, condense. Okay? This is the full package. Alright, next.
Remain the same.
Huh? Yeah, this one remains the same. Do you have to explain? No need to explain, you see? B, no need to explain. Just say it remains the same. Okay, no explanation needed because they didn't ask you to explain, right? So don't bother. So in the diagram, draw where the water droplets will be formed. In this one. Alamak, draw for you already lah. Right, so by right, you're not supposed to see this. You're not supposed to see because it's hot water now, so it's going to form inside. Clear? We clear with condensation, right? Are we going to see any more? Oh my god. It's evaporation. You know why? Because these are all school prelim papers. So you've probably seen this somewhere. Right? Or it could be in our intensive class. Right? Could have been. Okay, it was very hot. Mr. Lin did not have aircon to cool the room, he decided to hang 3 big pieces of wet cloth and use 2 fans. Okay, so to test his setup, he closed the windows and switched on the fans. The temperature decreased. Oh, okay. So this is a very interesting setup. So he don't have aircon, but he used wet cloth and fan to cool the room. No aircon, huh? No aircon. But how come putting cloth and fan can cool the room?
Because when you evaporate, then you condense, you lose heat.
No, that's not the key idea. What does the water vapor do? You see the wet cloth has got a lot of water, right? So also got a lot of water vapor, right?
Gain heat.
Yeah, very good. Gain heat from where?
Surrounding.
Very good. So it's like I absorb the heat from the surrounding and then I evaporate.
That's how sweat works.
Yes. So that's how you cool down. You understand? That's why you need to sweat to cool down. When do you sweat?
I don't.
Huh? You don't? No lah. You exercise, right? You run, no?
When I do that, I don't sweat.
Wait, you mean when you run, you also don't sweat? When you run really fast, like really, really fast.
Classmate call me alien.
Wait, you don't sweat? That's not possible. Everyone sweat.
No, I can't. I don't know.
So maybe your water evaporate from your mouth. You know? Okay, just an example, right? You know animals like dogs, they don't sweat, right? But how do they cool down? The tongue come out, then the water evaporate, so they cool down like that. Okay, so your water could have came out from different locations, right? Or different places. So that's why there is a cooling down. You understand? Okay, so that could have happened for your case. Is that okay? Right? Okay, so now let's come back to here, right? But I believe if you run marathon, you will perspire. I don't believe you will not perspire. You run marathon, confirm I perspire. Have you run marathon before?
I ran like.
Okay, what's the furthest you ran?
Like around the court.
Not fast enough, must go 2 kilometers, you know. Have you ran 1.6 kilometers?
I didn't.
You didn't? That's why you never experienced the perspiration, you see? Right, so if you ran like 1.6 kilometers, you're going to experience the perspiration. Okay, can you give me a minute? Can you try the rest first? Give me a minute, right?